Hi Year 9s, I'll keep trying to do some revision videos. If you like them, you could always request a couple more. So this one's about sequences, and it's about finding the nth term, for which I don't need that, okay? So we've largely focused in Year 9 on what's called linear sequences, and they're ones where the gap between the terms stays the same. Sequences where there is a common difference. Okay, so how would we find the nth term? What does the nth term means? First thing to look at is what's the interval, what's the difference between the terms in the sequence. If that stays the same, it's going to be one of these linear sequences, which means that this number is the one that goes in front of the n. Now, what is the n? The n is the number of the term, the first term, the second term, the third term. And look, I've done them all in columns nicely here. First terms, second terms, third terms, fourth terms. 3n, if that was the nth term, it would mean each term is 3 times its position. So, for example, position 4, 3 times 4 is 12. This is 3n. Right. Let's look at another one where the gaps are 3, a common difference of 3. So I know that the nth term is going to be 3n, but 3n without anything else as part of the nth term would start at 3. This one starts at 8. So this one is 3n plus 5, is one way of thinking about it. How else could we think about it? Well, pick a term. Pick the third term. If the sequence was 3n, the third term should be 3 times 3, 9. But that's 14, it's 5 bigger. One way of doing it. Another way that sometimes people like is, if you go back one term, if you invent the term before the first term, you would get plus 3, so take 3, you would get 5. That will be that, okay? So that is that, and this will be this, okay? So can we apply this to the next one? So first of all, we check that there is a common difference. There is, which means this is going to be 6n, and you have a choice. Either say that 6n would start at 6, but this starts at 3, which is 3 less, or say that the third term should be 18, but it's 15, which is 3 less, or go back and invent the previous term. So take 6 is that. Either way you do that, you get that as an nth term. And it's a linear nth term, because that's power 1, power 1, power 1. Right, let's have a look at the next one. First of all, look at the differences. Oh, take 2, take 2, take 2. They are the same, so we know it's going to be minus 2n. But the first term in minus 2n would be minus 2. This sequence would go minus 2, minus 4, minus 6, minus 8. Yeah, but that's 16 bigger than minus 2. Or, and this is where people particularly like this method, if you invented the previous term, remember this is the first term, there isn't really a term here, so we're inventing it. That would be 16, a plus 16. And then sometimes people ask, well, is that the same as 16 take 2n? Yes, it is. They're both the same, okay? The nth term. Okay then, how might we try and catch you out? We might give you a sequence that goes 3, 5, 7. And we're going to say more about these next year. So this is not linear, but hopefully you would spot, oh look, 1, 4, 9, 16, they are all the square numbers. And this number is in fact 1 squared. That one is 2 squared, 3 squared, 4 squared. This is the sequence n squared. And at this level, we might expect you to do something simple with that one. Okay then, why don't you pause the video and see if you can write those. So if you pause it now I'm not going to stop speaking because that would just be a minute of wasted time. I'm going to immediately start writing those in if you pause. Now I'm starting again, so there's still time to pause it before I write anything. So I'm going to check the differences. Right, they are all the same. That makes it linear. The previous term would be a 2. That one's 5n plus 2. Take 3, take 3, take 3. Minus 3n. The previous term would have been which is exactly the same as, we don't mind which of those. Right, how could we confuse you? Right, plus a half, plus a half, plus a half. All right, so they're still the same. So we don't change the rule. That number goes in front of n. What would the previous term have been? Oh, the previous term would have been nothing. So this one is half n plus nothing. That's fine, isn't it? We can do that. Half n plus nothing, half n. Right, what about this one? Plus 3, plus 5, plus 7. All right, they've changed. Now if I spot that that's a 2 and that's a 2, it's the same as this one, isn't it? We're not going to go crazy this year. So 1, 4, 9, 16. I've added 3, I've added 3, I've added 3. N squared plus 3 in that case. Linear ones and a couple of simple quadratic ones. Okay.